Welcome back to the channel. Mac DeStroir here to deliver another noggin nourishing knack for it episode. Today I'm going to show you a basic guide to replacing the thermal paste on your laptop CPU. This should help with not only thermals, but eliminate some irritating fan noise as well. If you've got a laptop that's getting a bit older now, stick around to see if it's worth your time. Now, some of you may have noticed that I've only had 2 or 3 videos posted to my account before this year. The number one reason for that was my main PC before the DeStroir here was a mediocre Dell laptop. It has an Intel Core i3. It's got 150 gig HDD, not an SSD, and 6 gigs of RAM, as well as the glorious integrated Intel graphics. Not the worst thing in the world if all you're doing is internet-based activities or maybe a little Photoshop work, but to try and use that thing for some serious workstation material such as rendering videos, it's really not a whole lot of fun to deal with. In After Effects, using standard 1080p video, just raw video, no effects applied to it, I was getting on average, like at best, 15 frame a second playback. It's horrible. It took upwards of 4 minutes to render 30 seconds worth of video audio playback. I worked with what I had though. I put this thing through hell and back, using various other softwares such as CAD software and professional audio workstations. Now, it's starting to show its age after all the torture that I've put it through. Boot times have become exceptionally slow and the fan sounds like a jet engine with Tourette's. It's time I resolve this issue. I'll be replacing the CPU thermal paste, cleaning the fan, and I'll be formatting Windows to a fresh install. So, a quick disclaimer before we jump into things. If you've got a laptop that's in warranty, I definitely do not recommend that you do this. And if you do decide to do this, make sure that you take the proper precautions so that you don't shock anything inside your system. Handling raw computer parts can be tricky sometimes, so make sure that yourself and your work area are static free and ground yourself if necessary. But do continue at your own risk. Now, the laptop that I'm working with specifically is a Dell Inspiron 15 N5050. So unless you're working with this specific model, this guide is not an exact representation of what you need to do, as most models will vary, guaranteed, internally. So, like I said, if you're not working with this model specifically, just kind of use this as a rough guide. So let's dive in and take the laptop apart. I'll start by removing all the screws from the bottom of the laptop. Keep your screws stored in a safe place so you don't lose any of them, obviously. I'll also remove the battery because there's one screw hiding under there as well. Now, these screws are what hold the main chassis together. Next, I'll flip it over, open the screen, and begin to remove the keyboard. This one here is held in place by a few plastic clips. With a small amount of pressure, you can gently pry it out. Now, I must be careful not to tear the ribbon cable that is connected to the motherboard. I'll carefully unplug it and set the keyboard off to the side for now. Under the keyboard, there are 2 more screws that I'll need to remove. There are also 2 more small flex cables plugged into the board. One is for the mouse and pointer touchpad, and the other is for the power button. Now I'll take a plastic spudger and separate the chassis. I'm being careful not to use too much force and break one of the clips by accident. Once all of the clips are free, I can remove the top portion of the chassis. Here we can see the motherboard, as well as the heatsink and fan that's attached to it that I'll be removing to clean. I'll start by unplugging the video cable and the fan power cable from directly on the motherboard. Then I will slowly begin loosening the 4 screws that are holding the heatsink into place. When the screws are free, I'll gently pull off the heatsink, and with that comes the fan. Now I can clean everything. I'll remove all the old thermal paste from the CPU, and as you can see, the south bridge here has a thermal pad attached to it. I don't have any thermal pads available right now, so I'll just be leaving that alone. After the CPU is all cleaned, I'll take the heatsink and clean all the old thermal paste off that as well. Once that's looking nice and shiny, I'll take some canned air to the fan to get out as much dust as I possibly can. Now everything's nice and clean, and I will apply new thermal paste to the CPU. This is a slightly different process than the desktop application. Typically on a standard desktop CPU, you want to apply enough thermal paste to cover the IHS without gooping over the edges. Now here we have some leeway, as there's nothing on top of the chip that the thermal paste is really going to affect at all, so getting some over the edge, as you can see from the stuff that I took off the factory put on there, is really not that big of a deal. I went a little heavy, yet still less than the stock amount. Next, I gently lay the heatsink and fan back into place. I secure the screws in an alternating fashion to maintain even pressure. Now I have to plug the fan power as well as the video cable back in. I can then reassemble the top of the chassis back in place. Make sure it's aligned properly, and then assure that all the edges snap together. I'll replace the 2 screws that I took out from underneath the keyboard. Then I will plug in the power cable as well as the touchpad cable back onto the board. Next, I'll plug the keyboard back into place and then gently snap it back in. I'll close the screen, flip it over, and then replace the screws on the back. Now I'll plug the battery back in and it's all set. Before I performed this little operation, I did a few tests to see if I gained anything other than the comfort of knowing that I have fresh thermal paste on the CPU. First, I tested the idle temps of the CPU with hardware monitor. I was getting about 44 degrees Celsius on average. Next, I ran the IDA64 extreme stress test to see what the CPU temperatures were like under full load. This kept at around 80 degrees C, and as you can see, it was throttling intermittently. After the stress test, I decided to see if that video rendering could be improved at all from all of this. I opened up the video project from last week. It's a 1080p video about 8 minutes long. The render itself took 42 minutes and 42 seconds in total. Finally, I tested the restart time of the PC. From an empty desktop all the way back to a functioning desktop. And by functioning, I mean all background processes have loaded and I'm able to open up Chrome and perform a Google search without any hangups. Before I performed the procedure, it took a whopping 5 minutes and 20 seconds just to restart and get to use my computer. My Windows 95 machine was comparable. So after replacing the thermal paste and a fresh Windows install along with my other main applications that I need, I ran all the tests again. Hardware monitor is now showing my idle temps at around 41C versus the previous 44C, so we got a 3-degree difference, not too bad. IDA64 Extreme is now showing 78 degrees C, which is a full 2 degrees less than what it was before. It's also showing a much more consistent CPU frequency with very minimal throttling. Now, rendering again the same video project from last week, I went down to 41 minutes and 2 seconds. It's only 1 minute and 40-second difference, but it's still an improvement. Now, the final test of restarting the machine is now complete in about 2 minutes and 34 seconds. That's about half the time of the previous 5 minutes and 20 seconds. But I will say that the most notable change from doing all of this is the fan. It is much, much quieter now. I don't have a decibel meter to show you the exact results, but let me tell you, it is so much quieter. This thing kicks on only about 10% of the time that it used to. So all in all, I'd say that it was definitely well worth the little time and effort that it took me to do this. I would absolutely recommend that you do this if you're experiencing inefficiency or you just happen to have a very old laptop. This thermal paste doesn't last forever and it will harden over time. I would actually consider this to be like proper maintenance that should be done once every few years or so. Now, I should have done this sooner, but better late than never, I suppose. What do you think? Does it seem like a worthwhile project for you to dive into? I think it does. Let me know in the comments below. That's all for this one. Thanks for watching. I hope you enjoyed the video and maybe learned something new for the day. Please leave any questions, comments, concerns, or recommendations for future episodes in the comment section below. I will surely get to you. Thank you again for watching, and you have yourself a wonderful day.